Okay, now again, we are in the space tab, and we have defined a new space. We have adjusted its parameters of floor area, ceiling height, and the building weight, and we have specified the usage and lighting information, people information. That all has been plugged in. The next step is to find out the wall which is getting the maximum sun exposure. So as stated in the earlier video, that would be this wall, the northeastern wall. It is situated between north and east, so it is the northeastern wall. That would be getting the maximum exposure. So let's find out its dimension, or it is going to be 51 feet, and the overall height would be same as we have found out earlier from the section, that is going to be 11.5 feet. So let's take these two values and multiply with each other to find the square footage of this wall, and that would be 586.5 square foot of gross area. Now there are there is window 1, type 1 window. There are two windows over here, as we can see in this layout drawing as well. And when we see in the section, we find out that these windows are 15.5 feet wide and 4 feet 8 inches tall. So as I have already defined the window in my calculations, so I don't need to do it again. But for you need to create new window, but we will see all the specs of the window. You can put two types of window per wall, and the software is pretty much limited to this. So I have created a new window and named it Auditorium. You can do this separately over here as well, here. So this window is named Auditorium. Detailed input is that the height and width parameters are given. The frame type is, as far as I remember, these walls are of a double glazed glass, so without thermal break. So I have added this. You can even change it to your own specs, your own findings, or your own problems. And outer glazing and inner glazing is given, and gap area is given. Normally these are default values. They work for multiple projects. If the window type or windows specs are not known, you can first you should try to find out those specs. But if those are not available, then you can go with these default values, and and your final calculations won't be affected that much. But you need to be specific over here. So we were on the spaces part. We were discussing the SMME. Similarly, wall was again, I have already created a wall, so we would be just reviewing its specs. But you need during your calculations, you would be needing to create a new wall. You can do it in the space by by going to this link, create new wall, or before starting your calculation, before inputting any data, you can go in this tab on the left side, and you can put it. So default wall assembly, the outside color is, I have set it to medium. You can edit it to your own liking or your own problem. Sometimes HVAC engineers do provide the inputs that what should be the outer paint, whether it should be the weather shield, or whether the wall should be insulated. So this is up to you. After that, you need to provide the layers information from inside to out. So first would be the 1/2 inch of gypsum plaster. Then, since this is a boundary wall, this is the most outer wall of the building. So this would be a typical 9-inch wall. Even if we can just find it out in the drawing. So this is 9-inch wall. The typical construction makeup of the 9-inch wall is there is half an inch of plaster. This is gypsum plaster. What we do in Pakistan, or in our most cases, it is cement plaster. But cement plaster is not available. You can edit the values by finding out from the literature and putting it over here manually. For instance, this is 0. This was 0.32. I am putting in 0.33. So you can edit it to your own. You can edit it to your own specs, but for time being, let's go with the available data. Then there would be a 4-inch common break, again 4-inch common break, and half an inch of plaster. This the overall U value for the wall would be calculated. And similarly, you can define the roof assembly. Now, when we see uh, in the section drawings, we come across that the final slab, the top floor slab, okay, this is the section, that is 6 inches, that is of 6 inches, 6 inches deep. So you can put in the parameters: half an inch of gypsum plaster, then 4-inch of high weight concrete, and half-inch of gypsum plaster, and you would be finding out the overall U value. So going back to the spaces, we have found out the walls. If the shade, if you know the shading information, I haven't put in the shade to make the calculation process a bit fast, but you can put in the shade information if you know that. Then the roof exposure, since the roof is flat roof, it is not inclined or at any angles, it's getting the exposure horizontally. We put in this area, this, and it will automatically find out the roof gross area from the calculation from the number we provided earlier from here. So in the construction type default roof assembly, while doing your calculation, you would be needed to create your own roof with the specs as provided in the structural drawing. But since I have already done that, I don't need to do that. Then infiltration. This type of information usually comes from the ASHRAE standards and experience. For time being, I haven't put in anything in infiltration. Infiltration is basically when air seeps in from cracks of doors and other openings, windows, and disturbs the overall thermal equilibrium of a enclosed environment. So for timing, we don't need to integrate input it. Then floor type. Since in our case our auditorium is lying on a space which is also air conditioned, as we can see in these drawings, that below the auditorium there is materials lab and then there is drawing lab. Both of them are air conditioned. You can see the air conditioners over here. So you need to check this function. However, if it is on the ground floor, you can put in any of two features: slab floor on grade or slab floor below grade. You can check these options. So this is above conditioned space. Then partition. This will be explained in detail in class, but since we are going with a single room, this is not needed here. Partitions is basically the way HAP knows that which room is situated with what type of room. So this is the primary purpose of this tab. You can do ceiling partitions and you can do wall partitions, but since we are going for a single zone, calculation. At this stage, this is not needed. Even in the latest versions of app, this tab has been abolished. You won't see this in the latest versions which are coming up, HAP 6.0, HAP 6.1. You won't be seeing this. So now this has been abolished and this is not needed, so I won't be discussing it further. So with this, we have defined our space, we have given the weather data. Now we need to put in the some system requirements. This is a package roof type unit. It's single zone. Rest of data we do need to provide fresh air, so ventilation air is checked. It is checked by default because rooftop package type unit is selected. So then central air conditioning. All of these are default data, default values. I haven't changed them. Here you would be required to you would be required from spaces to assign the zone from which you need to calculate the data. Then sizing data, I haven't tweaked these figures as well. These numbers are default values. And then if specific information about data equipment is available, like its compression information, or what is its compressor rating, how much power it consumes, you can put it in over here, but this is not needed. So let's actually ignore that. Let's cancel it. So once we are done with that, we can print view design results, and with this you can check as many check boxes, and your report would become as comprehensive. But I am just retorting to default, so I would only be seeing the default report. Okay. So the cooling load comes out as 15.9 tons. In the earlier video, I told you that already installed system, let's actually see that. That is 30 tons. 15 tons over here and 15 tons over here. So if the HAP is telling us that the total coil load should be 15.9 tons, then why the system is over designed twice its capacity? Well, the answer for that question is that you can see from this shaft, this chute, these openings, by the way, which extend throughout the building are called chutes or shafts. From this MEP shaft, the duct is extending and going to the auditorium, but it is going further down. This cross shows that this is going further down, and these it is being used to provide fresh air throughout the building, as you can see. So that's why it is designed a bit it is designed twice its size, because it is not just catering for the needs of the auditorium, the cooling requirements of the auditorium. It is also providing fresh air throughout the building. So with this we conclude our tutorial, and thank you so much for your time.